well, since it's 7:01, we'll get started. Hi, everybody. My name is Jessie Slafter. I am the newest member of the Redwood Heights Association Board. And I am just going to speak for about a minute or so before I turn it over to our team that's presenting today. And another thing I'll be doing is I'll be muting anyone who's making any sound that is not in accordance with the presentation. So don't take it personally. And the goal of Redwood Heights Association is we bring people together. We're dedicated to substantially improving the quality of life for Oakland residents by hosting community events and spearheading capital improvement projects, most notably with the rec center at the corner of also in Redwood Road. And this event specifically is sponsored by Deirdre Joyner at Red Oak Realty, and I'll put her website in the chat so you can access that if you would like to learn more about her practice. We have an upcoming event. The Redwood Heights Association has an upcoming event, a plant share on May 1st from 10 a.m. to 1 p.m. at the Redwood Heights Park. Also, that's the 3883 Aliso. And we'll have other events planned that are you can see at the Redwood Heights Association website. And to learn any more about Redwood Heights Association, to sign up for email notifications, and to support what we do by visiting rhaoakland.org. And I'll put all of that information in the chat as well. So this meeting, so just introductions wise, I think most of our folks that are, we have a couple people that'll be presenting. Anybody who has EBMUD after their name is also from EBMUD. And then we have the president of our board, Carla, if you, anything you want to add, but.
No, I'm good.
Yeah, and then this meeting specifically is a follow-up from the December meeting, and the video is available on our website. So if there's any, some preliminary questions can be addressed if you want to review that video on our website after this. And the staff are going to be reviewing the pipeline rebuild program, providing an updated timeline, additional details on the scope of work that's planned in Redwood Heights. So without further ado, I will turn it over to, I believe, to Marguerite.
Hi. Yep. Hi, I'm Marguerite Young. I'm the elected director for Ward 3, which includes Redwood Heights and a whole bunch of Oakland and a number of other communities, Piedmont, over to Rinda Moraga, El Sobrante, unincorporated parts of Richmond. I kind of hug the watershed, as I like to say. And I want to thank all of you for tearing yourself away from the president's speech. Kind of a different tone, but I'll leave my editorial comments at that. I'm joined tonight by our general manager, Clifford Chan, and folks from our pipeline rebuild team, as well as our community affairs folks, Mona Feverett Hill, who's the person for you to direct your comments to. And then I think Jimmy Yaloye and David Kelford, you're not speaking, are you? I mean, Carlton, you're not gonna present, are you?
No, David will do the presentation.
Yeah, so David Katsev and Jimmy Yaloye will be doing the honors tonight. So I'm just gonna, in the interest of time, turn it over to them and get us started.
Okay. Good evening, everybody. I hope that some of you remember me from the last presentation, and Dave is going to bring up the presentation on his screen. And I will start off by, David Katsev is our senior engineer in charge of our pipeline rebuild group at EBMUD. Carlton Chan, who was introduced earlier, he's the manager of our pipeline infrastructure division, and they both ultimately report to me, and I report to Clifford. So Dave, if you move to the next slide.
Okay. Let's see. Can you see the
So
slide,
first
Jimmy?
of all, yeah. Slides not, okay, there we go. So I wanted to briefly just give a recap of our meeting in December. At that meeting, I gave a picture overview.
Some sweet Tootsie Rolls.
I'm sorry?
I just muted that person, so go ahead.
Okay, so I'm planning to give just a big, in December, I gave a big picture overview of the pipeline rebuild program, talking about our overall pipeline distribution system, which consists of about 4,200 miles of pipe, which is a lot to maintain. We talked about the main breaks that we experience on our distribution system, and specifically focused a little bit on Redwood Heights. We talked about our pipeline rebuild, pipeline replacement rates. And I think I mentioned at that time that we are currently doing about 20 miles of pipeline replacement per year, and hoping to increase that as the years move forward. Just for a little bit of perspective, we try and do the worst of our pipe. We call them D and F pipes. We give them grades. And for perspective, we have probably on the order of 180 miles of D and F pipe in our system. So it is going to take us a while to get through them. So we have a process of prioritizing pipelines that we replace each year. And then finally, we did talk a little bit about design and construction workflows during that for the work. So that's just kind of a brief recap. I'm going to leave it to Dave to provide most of the presentation this evening, but we wanted to answer a few of the follow-up questions from the last meeting regarding our valve maintenance activities and how we deal with our valves. But the bulk of the time will be talking about specifically the projects that we have planned in the Redwood Heights area, and what the overall breakdown of the type of work is and the schedule for that work. So with that, I will turn it over to David.
Thanks, Jimmy. And good to be here with everybody tonight. So again, my name's David Katzev. I'm a senior civil engineer at EBMUD. I've been here for about 15 years. I lead what we have called here the Pipeline Rebuild Group, which is focused on all the planning and design work, really the front end work that goes into selecting our replacement projects. And as Jimmy said, you know, we have a lot of work to do in our whole service area. You know, the 4,000 miles of pipe that we do have, it's quite a big challenge to prioritize which pipes we really need to replace. But we have a pretty thorough, proactive process to really prioritize what are those worst pipes to replace. So let's get into what you're interested in tonight. I'm going to go a little bit more into detail on main breaks. I think this was discussed at the December meeting, but I'm going to get into it in a little bit more depth. Talk about just your neighborhood and what kind of geo hazards. Those are some kind of geohazard risks that you really have in your neighborhood that we need to consider during the design process. Going to talk about materials. What kind of materials can we put in the ground that are excellent materials and that are going to last. Give you some project updates, a schedule, and some next steps. So that's the agenda for tonight. Also, I think if you have questions, you can put them in the chat and we can get to them at the very end. And hopefully we can have a good discussion at that point. This is a picture just on the right there, just to comment on that, this is really the kind of work that you're going to see coming in your neighborhood. You're going to see an excavator there digging a trench for the new pipe. And typically it takes up about 1 lane's worth of work. So that's what's coming to your neighborhood. So here are the pipelines, and I think this slide was reviewed a little bit at the last meeting, but just in general, I mean, you've got 17 miles of pipe in your neighborhood. We call the 6 and 8 inch diameter, that's our small diameter pipe. That's what we call small diameter at East Bay Mud. But that's one of the most critical pipelines that we have in our whole system, because the 6 and 8 inch diameter pipe, that's connected to the customers. And those are the pipes that are connected to your homes. So mostly what you have in your neighborhood are these 6 and 8 inch diameter pipes. Average age, 69 years old. You know, the picture there at the bottom right there is typically what you have in your neighborhood right now. Those are cast iron pipes. You see a connection there with 4 pipes coming into a cross, is what we call that. That's what's under the ground right there. That's the stuff that's 70 to 80 years old. And that's what we're going to be coming in and replacing. One thing I do want to, as a main takeaway here, is even if something is old in terms of our pipelines, doesn't mean that we have to replace it. There's so many other variables that go into why we actually prioritize replacements. Age is one factor, but really it's how the pipeline's performing and the environment that it's in. You know, the main breaks, the geology of the land, you know, what decade of actually install was the pipe installed. Our 1930s and 40s cast iron pipe, that's our worst decade, or the 30s and 40s right there, worst type of cast iron pipe that we have in our system. It has a much thinner wall than other cast iron pipe, and it's breaking at a much higher rate. So here are the main breaks. The red, the orange right here, those are breaks that happened between 2010 and 2019. And you can see there were 66 breaks recorded during that time period. During calendar year 2020, there were 12 breaks, and those are in red. And I know some of these breaks caused quite a bit of flooding and damage, and I'm aware of that. In 2021 calendar year already, there have been 4 breaks in the area, in these right in here and over here. And just as a district total, there's 959 breaks that we had in calendar year 2020. So you can see that we have quite a few main breaks that we have to respond to throughout our whole service area. And this is just one area. So, you know, I've looked at one thing that we do in the design process is that we look really closely at reports on these main breaks. When we have a maintenance crew that goes out and fix a main break, they fill out a whole report and they talk about what type of a break it was. And then they also tell us what kind of a repair they used. And this can tell me a lot about what's going on with the geology, with the soil corrosivity in the area. And so I take a really close look, my whole staff, my whole team, we take a really close look at why are these pipes breaking in this area. I'm seeing a lot of ground movement in this area, a lot of you know, breaks up in this area right here where the joints are pulling apart or they're shifting right to left. I'm seeing some corrosion in this area combined with some ground movement. So just to give you a snapshot of stuff that I'm seeing on my end in terms of why these pipes are breaking. So this is a little bit of a follow-up to a question I think that came up in the December meeting about, I know there was a question about maps. How are our pipes all mapped and our valves, and how do we know what to do actually during an event? This is a screenshot from our computer software that simulates a main break. Actually, what I have here is a simulation when there's actually a main break that occurs in our system. it's a live event, okay? But right now, what I'm doing for you right here is I'm simulating something to kind of show you how we do our maintenance. The X here is an event, and so that would be a main break, and this is Jordan. This is Jordan Road right here, and here's Reddick Ave. So in this case, we just simulated a main break right here. This item right here and this are our valves. Okay, so you can see there are 4, I hope you can see my mouse going around. There's 4 valves here. That tells the maintenance crew which valves need to be shut in order to actually fix this main break. Once the maintenance crew actually finds out which valves to shut down to actually fix the main break, they'll go out and do that. The software then tells you how many customers need to be notified that are going to be out of service during this time frame. There's a process for repairing the main break and then finally flushing the water line and getting it back in service. So we have detailed maps like this for everywhere in our service area, showing valves, showing homes, showing customers, and we track this information as we actually fix a main break. So why do pipes break? First of all, corrosion. You know, we have a lot of cast iron. We have 1,300 miles of cast iron pipe in our system. The iron breaks down, the material breaks down, it corrodes over time. You lose the actual pipe wall thickness and the pipe breaks. So that's one way our pipes break. Ground movement. Of course, we live in a really seismic active area. You know, the last couple of earthquakes in the last few days, the ground moves, it shifts. And when it shifts, things get pulled apart. So there's tension, things get pushed together, there's compression, or things get bent in terms of, and bending, okay? Things move around. And these 3 diagrams right here are things that we think about when we're doing the design project. You know, if the ground right here, this is the ground, if it moves perpendicular to the pipe, it causes stresses on the pipe. If it comes at an angle to the pipe, again, causing stress, or if it moves parallel in the same direction of the pipe, it causes stress. We take all this into consideration when we're actually designing a new pipe system. Where is the tension happening? Where is the bending happening? And this is really what we need to dive into in a lot more detail in terms of your neighborhood because of the geo hazards in your neighborhood. And you know, the last thing that causes pipes to break in our areas is water pressure. I mean, we get surges of water pressure in our system that can cause main breaks. We have areas within our service area with higher pressure than others. And you can just imagine, you know, if you have an area with higher pressure and your wall thickness is corroding over time, that can lead to more main breaks as well. So these are really the 3 common reasons that why pipes break and what we consider when we're doing a design project. Okay, so what do we have in terms of our choices for pipe joints? The first one is unrestrained. And I'm gonna use this chain link here to really kind of show you what this all means. Unrestrained means the pipe is put together, one piece next to a piece and another piece. It's connected, it's sealed with a rubber gasket, but it's not locked together. And believe it or not, the majority of utilities across the country primarily put in unrestrained pipe around the country. Next up, which is a significant improvement, is what we call restrained pipe. And so this is where your chain links are actually locked together. Side by side, they're locked together. So as you go from one piece of pipe to the next, you have a mechanism to lock it together. And finally, the next one is a restrained with expansion and contraction. So here you have a chain link, the link right in the middle, can slide back and forth. This is really the ultimate solution. So this is one pipe piece put together with another and another, and the ability for the pipes to move back and forth at every single connection point. And that's really what we strive to put in where we have the highest risk related to ground movement, is the restrain with its expansion contraction. And I'll get into more detail in terms of showing you the actual pipes in another slide. Okay, so I've talked a little bit about geo hazards. What are your geo hazards? I'm sure you're all aware that the Hayward Fault runs right through your neighborhood. So this is the red dotted line right there is the Hayward Fault. The other risk you have is landslide risk. And we have a pretty detailed USGS map that categorizes different risks with different landslide areas. And there's some areas that actually overlap with the Hayward Fault that are pretty high risk in terms of landslides. So that's what you've got. You've got a challenging area to work with in terms of geohazards. So how do we know, what are the best solutions? What are the best pipe materials? And this is something I actually think EBMUD is really at the forefront of. In the past, 5 years, we've done a lot of work testing different kinds of pipeline configurations to see how they respond in different ground movement scenarios. The picture on the right here is from Cornell University, where they actually simulate a fault rupture. They simulate an earthquake. There's actually a pipe buried underneath here. It's the blue line. So the pipe is, 20 to 30 inches below the blue line. This is the fault rupture here. So this is actually after the test was completed. And so they created an earthquake here and to see how this pipeline would respond. We work with Cornell University. We also work with a University of Colorado at Boulder on testing some plastic pipe. Surprisingly, some plastic pipe together with some fittings can also be seismic resilient, can also move around and shift and not break and not fail during a ground movement event. So what are we doing in EBMUD? We're really focusing on ductile iron pipe and earthquake resistant ductile iron pipe as being very hazard resilient with proven results from these universities, and something called an IPVC pipe, which is a plastic pipe that also has some seismic resilient capabilities. So what we're going to do in your neighborhood is with ductile iron. So this is where I get into a little bit more detail here on the materials. What's coming into your neighborhood? What's going to be installed in your neighborhood? The first one is restrained joint ductile iron pipe. So that's the example with the chain link that just locked together, but didn't shift back and forth inside. This right here is basically the locking mechanism. So this is one side of the pipe. Here's the other side of the pipe. Our crews will come in and install this, insert one end into the other. And then there's a little joining mechanism where they install it inside the joint that locks it together. This one is the earthquake resistant ductile iron pipe. Now, hopefully you can see this, it's called a weld bead on top of the pipe. When we put this pipe into the ground and we install it, this weld bead can move to the right a couple of inches and it can move to the left a couple of inches, 3 to 4 inches of shifting. Every pipe piece is about 20 feet. So over the course of several pipe sticks, you have several inches of movement that the pipe can move back and forth. So we've actually targeted what we call the Norton cluster, and you're going to see that in a later slide for this restrained joint ductile iron pipe and the earthquake resistant ductile iron pipe for Reddick, Jordan, and Atlas. these are exceptionally good pipe materials. I can assure you of that. So let's get into projects now. Here's where we're at with projects. So recently completed, Harborview was a while ago. That job was done. The Quigley cluster is pretty much wrapped up. It's not within your neighborhood, but it's very close. But let's get into what's happening right now in my group. Right now, we're in the process of working on the design for the Norton cluster, which is 1.75 miles. It's a pretty good sized project for my group. And then upcoming projects are the Redwood Ave and Jordan Road, around 1,600 feet. The Barner cluster, which just touches the neighborhood a little bit, but obviously all these streets are connected, so there'll be traffic impacts that you'll probably see as a result of the Barner cluster. And then the Atlas cluster, which is over here. And I'm going to get into more details with each one of these projects. But that's what my group is working on right now. All of these blue streets right now. Okay, so here's the Norton cluster. And I don't know if you saw, but yesterday morning, about 4 or 5 of my staff were out on site walking the whole alignment. And that's one of the things that we do during the design process is once we actually come up with a pretty good plan for what we think is a good design, we go out with a group of people and we walk the whole alignment to make sure our design it's constructible and it's going to work. And we get a better idea of what kind of impacts that we have to mitigate once we get out there. So this is, 9,500 feet, the 1.75 miles. These are the streets we're covering. We're going to put in ductile iron restrained joint, all in this area right here. Zinc coating, the ductile iron has a new type of coating called zinc coating that helps corrosion protection. It's actually been used in Europe quite a bit. It's made its way to the US, and I think it's a really good advancement that the ductile iron companies are doing right now. What are we replacing? Mostly 1920s cast iron pipe in this neighborhood. So that's our first project right there. It's called the Norton Avenue Replacement Cluster. Oftentimes we just kind of pick a street to name these clusters where it's maybe we see the most main breaks. We really don't have a really good rhyme or reason to this. Actually, I've got on a side, kind of a funny note, I have 2 women engineers and they like to actually pick women names for our replacement clusters. The next one up here is our Atlas Avenue pipeline cluster. So this is just off of Redwood Road. It's on Detroit Avenue and then Atlas Avenue. This one is pretty much right. We've got the fault zone coming right through it. So we're going to put in ductile iron earthquake resistant joints. So for both these streets, you're going to end up with materials where at every single joint, you're going to have that little movement back and forth. And again, existing pipe 1920 to 30s cast iron. The third project that we have in the works right now is called Redwood Ave and Jordan Road Cluster. Here's Jordan, here's Redwood. Again, this is right in the Hayward Fault zone. So we're going to put in earthquake resistant ductile iron pipe, and again with the zinc coating, and we're replacing 1930 40s cast iron. So those are the 3 projects that we have in the works right now. So where are they at? The Norton replacement cluster, planning is complete. What's planning? Planning is, we look at all the hydraulics. We do the right pipe sizing. We get out there and we do some survey work. We collect all the utility as-built. We do a lot of work in the very beginning before we can jump into the design. Our goal is to complete the design June 2021, so just right around the corner. with a goal of hitting construction in the fall of 2021. And I just want to note these dates for construction, you know, they're subject to change. Okay, they're approximate right now. We have 12 different construction crews around our service area. And sometimes it's a bit of a juggling dance as we move them around. But that's our goal right now, is to get out there in the fall to start this project. The Atlas job, the planning is done. We're hoping to get design done this summer with a goal of getting out there in the winter for construction. And then finally, the Reddick Jordan replacement cluster. We're doing the planning. We're kind of in that stage right now with a goal of finishing our design by September, and then essentially a year from now to start construction. So that's our schedule with those 3 projects. So what happens? What to expect during construction? This is a shot of our pipeline crew. Typically they're about 8, sometimes 7, 8, 9. We flexibly staff our crews based on the job, but that's pretty much the size of the crew right there. You have a general pipe supervisor who leads the crew. You have guys that are plumbers that do a lot of work in the trench. You have heavy equipment operators, and you have truck drivers. So we have a whole crew, and they pretty much stick together for the job. You'll get a flyer like this if you're on the alignment or in the vicinity that shows you basically what happens during construction. The first thing we have to do is actually, saw cut. We have to get the alignment all set. We dig it out, we open trench it, we put the pipe in, we fill it with water, we test it, make sure the pressure can hold, we disinfect it, we do water quality testing. We do all the right procedures before actually getting it into service. After the pipe is live, that's when we have to come back and then we connect the customer laterals. So that's when we'll come back. Basically, we come by your house twice. We come by the first time when we put the pipe in the ground. We come back at the second time to actually connect your service to the pipe. After all that work is done, then we come out and do our final paving, and we coordinate this with the city of Oakland. That's what you can expect with construction. So what's next up for us? So design, we have a lot of work to do in design right now to complete our projects. You're gonna see us out in the neighborhood a little bit more doing our job walks. So we'll come out for the Atlas job to do a job walk. We'll probably come out a few times to do the Reddick Jordan job. There's some challenging things with that job. So I was out there the other day. I think you'll probably see me more often out at that area. There's lots of coordination and permitting to do. Of course, we want to make sure we're coordinating with other utilities, with the city in terms of their paving plan. So we do a lot of work in terms of coordination before we actually get out there for construction. There's the permitting part, and then there's scheduling construction. And so that's it. That's really where we're at with our projects. I know there's been a lot of main breaks in the area recently, a lot of concern, but I think we've got some good plans to come into your neighborhood and to put in some pipe that's very hazard resilient and that's going to last. So I think I'll stop sharing my screen.
There's some questions
in the chat.
Yeah. I guess I'll kind of moderate the questions in the chat, Dave, and then you or maybe Carlton can follow up with answers. But
great.
The first, I guess, series of questions have to do with the main breaks and are these main breaks listed anywhere, and how can they check to see if there's a break near their particular residence. You kind of, talk about how we track our main breaks. Dave or Carlton?
The way we track our main breaks, we'll get updates on, I get updates on the main breaks all the time. And so I'm looking at that data constantly. And we track the main breaks. Our asset management group collects all that data and tracks it for the whole year.
David.
Yeah.
Maybe if people have a particular question about a main break in their area, if they can get to either Mona, we can look up that particular area. And there's another question about the water pressure being significantly less. If we get the address, we can get staff out there to check. It is possible sometimes that a valve wasn't open completely, and that might result in lower pressure. So if we get that information, we can send out staff to check.
Okay.
Okay. There's a question about kind of our corrosion protection. The specific question is that expansion joints don't solve the corrosion issue. And I think you talked a little bit about the zinc coating, and you may also want to add about, some of our cathodic protection procedures.
Yeah, there are actually a number of things we're doing to solve the corrosion problem. I think the first thing we're doing is we're getting extra thick pipe. Okay, so that's the first thing. The second thing is that there's an extra coating around the exterior of the pipe, the zinc coating, to prevent corrosion. The third thing we're actually doing in one of the pictures, I don't know if you saw, but it was a white covering. It's a white bag that goes over the pipe. That it's called a polyethylene wrap. That wrap around that significantly reduces corrosion. So there are a number of things that we're doing to actually reduce future corrosion for this ductile iron pipe.
See, the next one has to do with, and I think you alluded to this a little bit, David, about the closed section on Reddick seems like a particular challenge for installation. I know that's one you said you had just gone out to the site recently.
The close, which side of Reddick, I guess, is this question? Is this on the Norton side for the Norton cluster, or would this be closer to Jordan? I guess if I could get some clarification on that question.
The closed section of Reddick is between Jordan and, I believe, Harrier.
Wisconsin.
So is that the area actually where just people walk through right now?
Yeah.
That's right.
Yeah, well, there's no, okay, so good question. There's no pipe up in that area right now, so we're not going to be getting up in that area and replacing pipe. What we'll have to do on either end of there is to maintain access. So whenever we come in and we do work, we don't close the entire road to traffic going from one point to another. We always allow customers to access their homes or a way for people to walk around the construction site and go through the road. So hopefully that answered your question there.
Yep, thank you.
Dave, you talked about the zinc coating, but there's another question. I just want to stick to the zinc coating. There's a question about the zinc and water quality, and you can explain that the zinc is not touching the water, and maybe explain the mortar coating for the ductile iron and what the pipe looks like.
Oh yeah, the zinc coating is on the outside of the pipe. And so there's no area on the outside of the pipe that's going to touch our water. On the inside of the pipe, which is pretty typical for years and years, we've lined our pipe with cement mortar lining. And then there's a little coating over the cement mortar lining, all tested and approved by AWWA standards for water quality purposes. So the zinc is not getting anywhere near the actual water.
See, there's a question about repaving the whole streets. Whether we do that after the job is finished, and maybe I'll start with this, and Dave, you can add to it. This is an area that we've been working pretty hard with with a lot of the communities that we work with, and particularly the city of Oakland. Our obligation when we install a new pipe is to really repave the area that we trench in. The city of Oakland has some requirements for doing a little bit on either side of that particular trench. They call it a T-cut that needs to be repaved. But we've been trying to reach agreements and coordination with the city of Oakland to do more paving than what we're obligated to do. That's an area, in some areas we've been able to do that, but we can't repave the whole street without that coordination with the city of Oakland, since they would be responsible for portions of the street that we don't touch with our pipe installation. So it's not consistent from one job to the next. It really depends on agreements and coordination that we can reach with the city to do a paving beyond what we would be obligated to do for the trench. And then the last question I see here is, what are the residents without water during construction? And if at all, that would be for a short period, but Dave, maybe you can expand on that.
Yeah, it's typically a short period, and customers are notified well in advance when the water is going to be out of service. But it only happens during the day for an hour or two, and then you're back on with water. So
you might want to explain very quickly that we leave the old main in service while we construct the next one. So maybe you want to go into a little bit more detail there.
Yeah, I mean, the old main, typically what we try to do is we try to put the new main right next to the old main. I mean, that's kind of the ideal situation, so that when we come back, the pipe is live, meaning the new pipe has water in it and is pressurized. At that point, you still have water service, okay? And so what we'll do is when we'll come in, we'll dig right in front of your house, and we'll remove the tap that goes into the old pipe, and we transfer it onto the new pipe. And during that time period is when you actually would lose water service. But those taps, we do, I don't know, it depends on a day, but we can do about 10 per day. So, an hour or two of when you might be out of water service is kind of typical. Hopefully that makes sense.
Yeah, the other thing, David, is when we do make those transfers, we do provide information in the mailers and on our website, because when we do that transfer, you're out of water, there might be some air in the line. So we provide instructions on how you can flush the lines in your house. And that's when you might actually experience that some impact from that transfer, but we do provide all the information on our website.
I think there was a question about what is the timeline for Jordan Road. And, I mean, we're over the course of this summer, we're going to be doing the planning and the design work. And I think I covered that in one of the slides. The Jordan Road, it's a little bit more challenging. Jordan Road, you actually have two pipes in your street. You've got, on one side, you've got an 8-inch cast iron pipe, which has been breaking. On the other side of the street, you have a 16-inch steel pipe, which is more of a transmission pipe. So we need to do a little bit more research, investigation with all the different utilities in the street to make sure of where our design is really going to work in that street. So it's a little bit more challenging, and it'll take a little bit more time.
Let's see. There's a question, and I don't know, Clifford, you might be able to best answer this. I'm not sure, but when a break does occur, how long does it usually take for EBMUD staff to respond and turn the water off when a break occurs?
Yeah, from the time that we get the call that there's a break, so not maybe when the break occurs, but when we get notified of the break, and when we get someone out there, we try to get out there, within the hour and faster than that. We typically don't try to turn off the water completely. We try to leave a little bit water running, because if we it depends on the type of break, but for a typical smaller type of break, if we shut off the water completely, that brings in contaminants into the pipe, and we don't want to do that. So we leave a little pressure in the pipe to let it run. Then the crews will get out there, and then they'll do all the work. Usually they can do the work when the pipe is still live. Sometimes they can't, and depending on the type of repair, will also determine how extensive the flushing will be afterwards to make sure that we flush out any materials that got into the pipe.
Let's see. I think there's one last question, Dave, I think you kind of talked a little bit about this, but does this work only directly affect the residents on the street, or does it go beyond that? And I think, the actual water service impacts affects probably the people on the street. But obviously with construction occurring, you'll see the trucks, they'll be going back and forth from the job site. So there will be some of those impacts to other residents in the area, depending on what streets the trucks go down.
Right. I mean, yeah, there'll be some detours. Maybe if we can close the road here or there, you're going to see trucks coming in and out of the neighborhood. Every once in a while, one of our shutdowns has to extend a little bit further beyond our project area, but that's a unique situation. So it's yeah, I mean, a little bit here and there outside of the neighborhood, but mostly it's restricted just to the actual job extents in terms of the impacts. And it's really like a train, it's a train moving along. You're going to see our crew kind of move alongside your house, and we can go about 200 to 300 feet per day, and then it's going to, and then you'll see them move down the street, and then you'll see them come back and redo your customer services. So you'll see them a couple of times if you live on one of these streets. And our crews are really, they're all, if you ever have any questions, you can always go up and ask them questions. They all pretty much know, they have lots of good information that they can pass on to you also.
Let's see, I see one last question, and I'm not sure about what we're getting at here. This one says, we have no curbs on our street, and how will you help protect our property? And I'm not sure whether you're talking about during construction or whether you're talking about main breaks.
So it might be both, Jimmy, but for main breaks, this was a question that came up at the first meeting about the main breaks, and there was another individual from EBMUD that was looking into that. I think maybe the something related to construction, when we do all of that flushing, David, and there's no curbs, how do we make sure that water, when we flush, doesn't end up into people's property? And you can answer that one.
Yeah, I mean, that's a good, we would pick points in the project where the water would be coming out of the pipe that would be very close to a storm drain. We're not gonna pick points to flush our pipes where it's gonna impact any of your homes. We think very carefully about that when we actually design our projects. And we actually install certain points in the projects where the water can come out and our flushing points. So that's carefully thought out before we actually get out there and do that.
And maybe you could talk in some areas where we put the tanks out there, the Baker tanks, David?
Yeah, so a lot of the water that when we do our chlorination at the very end, we can't just take that water and dispose of it down the storm drains. We have to hold it in place for a while, and we have to dechlorinate it before we can actually put it into the storm drains. So as we call them Baker tanks, and they're big green storage tanks. And our crews, when they go out, like a month or two before we actually start construction, and we really look for ideal spots to put these tanks that don't impact the customers that live in the neighborhood. So we put some special thought into placing those appropriately so it doesn't impact your daily routines in your life.
And I would just add that in our board meeting yesterday, when we made our drought declaration, that one of the points that was made and requested is that we look into ways to not end up dumping some of that water that we end up having to flush. So that will be also incorporated as we proceed through this drought year, when we're asking all of our customers to voluntarily cut back 10% of their water use. We'll be doing as much as we can to not have any drops that don't need to end up down the drain.
I think I also saw one more question that I didn't hear you answer, about influence on water quality, long and short term.
Yeah, I saw that question. I mean, short term, long term, the pipe materials that we put in, not meet and exceed all the standards. The quality you have now and the quality you have going forward, there's not going to be a difference that you see in terms of the quality of the water. The only thing I did want to mention is during that short period of time, like we mentioned, when we transfer services, that's when you might notice some air. And sometimes when you have air in the line, you might have some particles on your pipe. And so your water will come out and it'll look a little dirty. And that's why we ask you to flush your house lines after we make that transfer, because you might think that we introduce that material into the pipe. That's why we do the flushing, to get all the material out, but you may have some sediment in your system. And so we just want you to be aware of that. So that might be a short-term water quality issue you see, which is why we put all the information on the flyers, which links onto our website to tell you what to do to flush if you do notice that issue.
I think Mona added something else in there that we do sometimes stage our pipes and materials on the street. Ideally we look for a vacant lot or some area close to the neighborhood where we can store all of our materials for the job site. Sometimes that's not available. And when that's not available, we'll pick a spot within our job site to actually store the pipe, store some of the fittings. So it may impact parking, but we try to be strategic in where we pick those spots to lessen the impacts on you.
Okay. All right. I don't see any more questions in the chat. Oh, I see your hand. So the question is, how long will the construction on Jordan Road take? And
well, if we're I like to look at a whole job together. So Jordan Road and Reddick together. I kind of like to look at that as one project. That's going to be earthquake resistant ductile iron pipe. Of course we try to get in there and out as quickly as possible to lessen the impacts on you. But I'm going to say for that job, roughly 3 to 4 months in terms of construction. Could be faster than that, but I'm just going to take a guess at 3 to 4 months right there.
David, does that estimate give you include paving?
Yeah, that includes paving.
okay. If there are no more questions, we thank you very much for your attention, and we are, we're happy to make these presentations, and hopefully this gives you a good idea of what to expect in the next year to year and a half.
Thank you so much. I appreciate you all presenting, and As we noted, any other follow-up, feel free to go to rhaoakland.org to see our upcoming events, and that this will be recorded. And then as they noted during the presentation, any other follow-up questions can be sent to Mona, who put her email address in the chat as well. So I think with that, we'll close it out and stop the recording, and we appreciate the presenters and all the attendees that came tonight.
Yeah. And Jesse, maybe especially for the person who had commented about their water pressure, if you can get the address to Mona and we can follow up on that.
Great, thank you.
Thank you, everybody.
Thank you.
Thank you.
Thank you.
Bye-bye.
Good night.
Bye.
Thanks. Thank you.
Good night.
Thank you.